technically, these things over here are exactly that, right? They're things. And things is the third letter in IoT, Internet of Things. But today, we're not talking about the T in IoT. We're talking about the I in IoT. So we're talking about this. Code. We're talking about code. But there's going to be a lot of code. We're going to write some code. We're going to talk about some code. So I'm just warning you, there's going to be code. OK. So before we get there, let me introduce myself. My name is Gergana, but I usually go by Jerry because that's a little bit easier to pronounce. And I was one of the people who was lucky enough to have a weird enough name to get a gergana.dev website and not pay a premium for it. And I work for a company called BBD. At BBD, we make custom software. But I work in the R&D team. And being in the R&D team, it's kind of difficult to define what we do. And on paper, we do consulting and training and research. But in real life, the more fun things that we do is do things like building meme generators and replacing keyboards with fruit, and my personal favorite, programming astromech droids. This is kind of how I got to be here today. I got a little BB-8 toy, which I hacked with JavaScript. And for those of you who were at DevConf last year, you may have seen my talk on that. And I don't really settle for the apps that get provided to us with robots. They don't do it for me. As an example, a few years ago, I got a drone. Really fancy drone, comes with this fancy controller and a fancy app that you download from the Play Store or the App Store, whichever operating system you use. And I played with it for a day, and then the next day, I decided to hack it with JavaScript. And this is how it went. Hoping the video will load. Cool, it's loading. It's a very simple take off, hover for a couple seconds, and then land. Simple, right? I thought it was amazing. I mean, I was so impressed with myself. I mean, it's just a JavaScript, like 4 lines of code. And later that evening, my husband came home, and I really wanted to show him what I'd done. So I grabbed the drone, took him outside, put it on the grass. But this time, it was dark, so I don't really have a video of that. But this tweet came out shortly afterwards. All right, so what I'm saying with this is that you are probably going to crash some robots into some walls, and you are probably going to explode a couple of things, but that doesn't mean you shouldn't try. Now, in preparation for this talk, I watched a lot of IoT talks. One of my favorite ones divided IoT into 4 different main sections or ideas. There's a reference to it at the bottom there. And what it spoke about is that IoT firstly consists of hardware, which makes sense, right? The devices, the things that do stuff. We're not going to talk a lot about the hardware because, as we said earlier, we're going to be coding today. Then there is the data. All of these devices produce data, lots and lots of data. About 9 out of every 10 talks I watched referred to that Gartner study that says something about millions and millions of petabytes of data by the year 2020. So lots of data. And then we get the software, the part where we come in. We write software to extract that data out of those devices so we can do useful things with the data. And lastly, we get probably the most important part of IoT, or the I part of IoT, the connectivity. Because we need to connect those previously dumb devices like kettles and light bulbs and fans and whatever it is to each other and to the internet in order for them to share that data and do something useful with all of this data that we have. So let's get to it. So the hardware we're going to be using today is a bunch of components from a company called X in a Box. It's a really cool company that makes these Lego-like electronics that plug into each other. So you don't need to understand the wires, and you don't need to understand the voltages. You don't need to have learned all of that stuff in order to play with these things. We're going to have two devices. The first device I'm going to refer to as the sender device. This is the device that's going to consist of a number of sensors, and these sensors are going to gather data and send it to the cloud. The sender device consists of a little programming interface, so we can upload code to it. So this is just a little chip that you use to power the device or to upload code. Then we have the actual core chip. So this chip here is the one that has a Wi-Fi connectivity, Bluetooth connectivity, and stores the information that you've uploaded. And this chip is actually equivalent, to those of you who've played with these things before, to an ESP32. It's just the X in a Box version of it. Then we're going to have a little screen. We're also going to have a little capacitive touch sensor. So the point of the capacitive touch sensor is so that when you connect your lights and your fans and your air conditioners to the internet, but you get home and there is no internet because load shedding, I don't know, you can still turn on your lights. Okay. Then we have a little light sensor to sense the amount of light in the room. And lastly, a temperature sensor. On the other side, we're going to have our receiver device. The receiver device is going to get data from the cloud and do something with that data. Interpret it and make things turn on or off. The receiver device, the first four, are similar to our sender device. The only difference is that it also has a little relay, so it can control something else. Then the data. So we have all of these sensors, right? We have a light sensor, temperature sensor. All of these sensors produce different data. And this different data, we're not going to use all of it. We're just going to concentrate on a subset. So the light sensor, we're going to get light and proximity readings from. The temperature sensor, we're going to get temperature readings from. And the capacitive touch sensor, we're going to get touch readings from. Now let's get to the software. So these devices are quite limited in terms of processing power and memory because they're quite small. So you usually need to program them in some sort of low-level programming language. So your options are C, C++, or Python. I'm going to be using the Arduino IDE, which is mostly C. But I really like JavaScript, so we're going to throw some JavaScript in there too. Let's get to it. First demo. Now, when I was practicing this talk, a couple of people asked me why I have my dogs in my demo slides. The reason is because demos are stressful and my dogs calm me down. All right, I'm going to sit because I need to actually code. So, okay. All right, so this is actually Visual Studio Code, but with the Arduino IDE extension installed. It just makes it easier for programming for me, at least. And with the Arduino IDE, you usually start with these two methods, a setup method and a loop method. The setup method is the thing that runs every time you turn on the device, and the loop method is the thing that carries on running continuously on the device. First thing we're going to do is import a few libraries. Now, these libraries come from the X in a Box GitHub account. Their chips are based on other popular chips out there, but they create wrappers for those chips so that it's easier for you to program with their devices. And we have our four sensors, three sensors, sorry, screen, relay, and light sensor. Inside the setup, damn it, Visual Studio Code. I apologize, this will be quick. Practiced it a few times and it keeps doing that. It's a feature, yeah. Your snippets stop working. I love Visual Studio Code, but not when it does this. In our setup method, we're going to start up all of our sensors. So we're calling begin on all 3 of the sensors, and then on the light sensor, we're enabling the proximity part of it, and we're setting the proximity gain. So the proximity gain is a measure for the sensor to determine pretty much what the lighting conditions in the room are. So if you set this to something really low, a small dust particle could set off your proximity sensor. For this kind of lighting, I've tested it in a few rooms similar to this one, 2x seems to be the right one to use. And then we delay for 5 seconds to allow all of the sensors to stabilize once they've started up. Okay. Then, inside our loop method, we're going to listen for something getting close to the proximity sensor. So we're going to get the proximity. If that proximity is over 100, we're going to turn the relay on if it was off, and off if it was on. And then just at the top here, what I'm going to do is initialize the initial state of the relay to off. And we turn the relay on or off by passing high for on and low for off. Okay. Now we need to upload this to our device. The device is currently plugged into my USB port. I'll show it to you in a second once it's uploaded, so you can have a look what it looks like. As you can see, Visual Studio Code doesn't actually deploy stuff itself to the device. It's still using the Arduino IDE in the background, so you still have to have it installed. You can see it starting up over there. Then, once it's uploaded, which should be soon, a few other important things. At the bottom here, you can see which USB port I'm using. That can be set from Visual Studio Code. You can see what board I'm using, so the ESP32 dev module, and you can see what file I'm uploading. All right, so this is ready, and I'm just going to plug it in here so I can show you. Have a light plugged into the relay, and when I get close to the proximity sensor, the light turns on. Cool. So now we have our first receiver side of things set up. Let's set up our sender. Cool. Close and reopen. Have you tried turning it off and on again? It always works. It's best advice. All right. Now, the difference with the sender device is that instead of the proximity sensor, we're using the light sensor. So that's going to send light data to our cloud later on. Otherwise, everything else is pretty much the same. Then inside our loop, we're going to detect the touch on the buttons. So as you saw in the picture earlier, it looked a little bit like a PlayStation controller, the buttons. So we're going to listen for a circle and a square touch. If it's a circle, we're going to print out the light in the room, the amount of light. And if it's a square, we're going to print out the temperature of the room. So let's do that. Light goes there. And it's measured in lumens. And temperature goes there. And that's measured in degrees Celsius. Now let's actually read those values from the sensors. It's pretty easy to read the values. So to read the light, we just call light sensor.getAmbientLight. light. Simple enough, right? And to read the temperature, we set poll on the temperature sensor, and then we say get temperature in degrees Celsius. If you put an F there, it would give it to you in Fahrenheit. All right, so this part, because it's this little sensor over here, I can't really show you because it just displays on the tiny screen. So I'm just going to show you the video of it. So you can see it prints out sensors ready. When we touch the square, it prints out the light. When we touch the, or other way around, when we touch the square, it's the temperature. Circle, it's the light. If we cover up the light sensor and touch the light again, the light reading is only 1 because there's no light. Okay. Cool. So now that's great. We have these sensors, and they're getting their own data, but it's still not actually doing anything more than a light switch does, right? Or a thermostat on your wall at the office. So what are we going to do to fix that? Well, we're going to connect the devices. And for that, we're going to use the MQTT protocol. Now, the MQTT protocol was created specifically for IoT devices, and it works really well on IoT devices. And it's made for small, limited devices to work, to communicate. And with that, we also need some sort of cloud. Now, your cloud providers, you have different options. I've tried in a few different ones. The one we're going to use today, mainly because I still have a bunch of free credits on it because I registered on it recently, is Google Cloud. IoT Core. The Google Cloud IoT Core is really cool and actually really nice to use because when you make mistakes, it gives you a link to where you can go to fix your mistake. So that's pretty cool and useful when you're first starting out. There are 2 ways to set up IoT Core. One way is through downloading and installing the SDK and doing it in your terminal. The other way is the way I call the clicky way, opening the website and clicking on the buttons to create it. I'm going to tell you about that way. So what you do to get started is you go onto Google Cloud, you register your profile, and you create a new project. In the side menu, you would then go and select IoT Core, and it will prompt you to enable the IoT Core API. Once you've enabled that, it will prompt you, would you like to create a device registry? Now, the device registry is where all of your devices sit. It's like a little package of all your devices, so they're all in the same place. For your device registry, you need to create 2 publish-subscribe topics. There's 2 because there's one for telemetry data, and there's one for configuration data. You can put them in the same topic, but it's not recommended because you need to keep those 2 types of data separate. Once you have your device registry and your pub subtopics, you can start creating your devices. The way that devices are secured on IoT Core is by public and private key pairs. So you need to create a public-private key pair. You use OpenSSL in your terminal to do that. And the algorithm we're going to be using today is the elliptic curve one to create our public-private key pairs. And you create your device and put the public key on Google Cloud, and you keep your private key safe. Do not upload it to your GitHub account accidentally or on purpose. All right, once you've got that, you can create your devices. Now, important thing to remember when creating your devices is what you name your devices. You can't change the name once you've named them, so you have to delete them and recreate them if you want to change the name. So name them something meaningful. All right, demo number 2. This time we're going to start on the sender side. We're going to take this light and temperature data and send it to the cloud. To do that, we first need to include a few new libraries. 7. The libraries we're including is firstly the Wi-Fi library for the ESP32 so that it can connect to the internet, the MQTT library, the Cloud IoT one, and Wi-Fi client secure, so we can secure our data when we're sending it. First thing we're going to do is connect to the internet. Wait. That's just initializing some stuff which I needed to do over there. Just initializing a few variables at the top. So let's connect to the internet. Now, there's a whole lot of print lines in here. Those are mainly for debugging purposes. It just prints stuff on the little screen, so I was using it to see whether it was actually connecting. The two important lines are line number 41 over here, which says Wi-Fi.begin, and you pass it your Wi-Fi SSID and password. There is a way to connect to enterprise Wi-Fi, but it's quite difficult and very finicky. It disconnects quite often from enterprise Wi-Fi, so it's easier if you don't have to do that. And then Wi-Fi status. You check the Wi-Fi status. If it didn't manage to connect successfully, try again in 5 seconds time. Next thing, so with these little chips, they don't have their own little batteries, so they can't keep time. They don't know what the time is. But in order to communicate with the cloud, you need to know what the time is in your zone. So we need to actually set the time on the device. And we're going to use the Wi-Fi in order to do that, because we're now connected to Wi-Fi. And we do that by this magic incantation. We need to call these two inside setup. So we're going to call init Wi-Fi and sync time. Now we're ready to connect to the cloud. In order to connect to the cloud, we're going to first create an IoT core device. And this is the part where I need to show you this demo config. Now, the demo config is not my actual config, because I can't show you that, because then you'll see my private key and you might take a photo of it and steal all my Google Cloud credits. So you put in your Wi-Fi SSID and password in your config, all of your settings for your Google Cloud project. So your project's name, what location your project is in, the registry for your device registry, and the actual device's name. To create your public-private key pairs, you use these commands in here. So this is the private key one, and the second one is the public key one, based on your private key. And then you run this command to get a text version of your private key. Your private key that you get in this case will look exactly like this. Okay, this many characters. It will be this many characters. And then the last thing you need to do is get the root certificate for MQTT on Google. Okay, so the bridge that we're going to be connecting to, so we can secure everything with these things. And then in our init cloud method, we're creating a device using all of this information. We're creating a new secure client. We're creating a new MQTT client, and then attempting to connect to it. Once that's done, we need to add a few more methods at the bottom here, which are going to help us send data to the cloud. The first one is to create a JSON web token in order to be able to send data securely to the cloud, and so that the cloud knows the device is the device it says it is. We do that like this. All right, so we're double checking that if we already have a JWT, it's not expired. If it is expired, create a new one. Oops, turn the fan on. Gave some of my demo away. Damn. Then we can connect to MQTT and start communicating with it. So we're going to try to connect to the device by passing in the device's client ID and the JWT. And we're going to try it a few times, every second, just in case it doesn't work the first time. Once we're connected, we need to subscribe to the config and command topics. And I'm going to explain a little bit more about what those do in a few minutes. Now we need to call this connect. So every time we go into the loop, we're going to check if we're still connected to MQTT. If we're not, we're going to try to reconnect. And we're also going to double check that we're connected to Wi-Fi, and if not, reconnect. Once that's done, we can now send our data. Before we do that, what I'm going to do is just take out these two and put them inside variables. So I'm going to call this one light. And I'm going to say light. And get the light reading. And I'm going to call this one temp. And put it over here. Float temp. And set it to that method. Now we're ready to send data. And to send data, we're going to call this. So we're going to put it inside a string, the light reading, and then the temperature reading. And every 5 seconds, we're going to send the light reading. Then the next 5 seconds, we're going to send the temperature. And then carry on, so that we can control both things. Right. The reason I've put them in like this is because, remember, we're going to write some JavaScript, and we can pass this to JSON. Now, at this point in time, I can't really show you what the sender is doing without first fixing the receiver part, because the sender is kind of boring at this point in time, right? So let's make some changes to the receiver. Get rid of all of that code and put this code. This code is pretty much exactly the same as what we wrote earlier, except it now has the Wi-Fi connection, the syncing the time, and the connecting to Google Cloud. All right. We're going to make a few small changes to it. On the receiver side, we need to listen for when messages get sent from cloud to the device. So in here, we're going to add a listener. So on message, we're going to execute a method. What will that method do? Well, for debugging purposes, we'll print the message that we received. And then we'll check if the light in the room is less than 50 lumens, turn on our light. And if it's more than 100 lumens, turn it off. And you would be forgiven for thinking that this is it. But it's not. There's one last thing we are missing. And that is, this method here only gets called in the setup, if you remember, right? Which means that when our device is looping, it's no longer checking whether this messages are being received. So we also need to tell it to check for that. And we do that by telling the client to keep looping as the device is looping through its code. All right, now we need to upload this to our device. Make sure that the wires aren't actually touching. And hit the upload button. All right, now this is going to take a little while longer to upload than the last one because it's more code. So in the meantime, while it's uploading, does anyone have any questions? Yeah?
Are the X-in-a-box APIs compatible with similar devices?
Yes, so all of this code, especially the Google Cloud stuff that we're writing right now, can be done with a ESP32 and a temperature sensor, not the X-in-a-box specific ones.
Are you going to make the sample code slides available?
It's on my GitHub, which you can get by going to my website. all of this, my slides and everything is on my GitHub, so you can go and check it out. It's done. Is it done? Is it done? Please be done. Yes, it's done. Okay, awesome, awesome. All right, so now what we're going to do is we're going to go here and exit that. Go to Google Cloud. So this is my device in IoT Core on Google Cloud's website. Remember earlier I said to you, I explained the command and config thing a bit more? Well, this is where you control those things from. So you can send config and commands to your device. So we're listening to configuration updates on our device right now. So if I go to update config and I send, it was less than 50, right? So let's send 30 to the device. And if we send 300, turns off. Same thing for my little device over there, which is set up in the exact same way, same stuff, except it has a fan rather than a light. So we can go update config, and for this one, it's the temperature. So if it's over 30 degrees, fan should turn on because it's too hot. If it's less than 20, fan should turn off because it's too cold. So let's say 32. And 16. Now fan turns off. Now, all this stuff is really cool. But what do you do with it, right? We have a receiver, we have a sender. We now need to connect these two. Well, you have a number of options. You can use data flow, Google Cloud. You can use cloud functions. Using cloud functions, you can push your data to Bigtable and store the data. You can put it in BigQuery, make changes to the data. You can even put it inside machine learning and learn from the data you're receiving from your devices and then make your lights turn on and off automatically without even having a sensor anymore. But I promised you JavaScript. So we're just going to use cloud functions because cloud functions work well with JavaScript. One of the examples I saw on something similar to this, it was using a temperature sensor similar to the one I'm using, but that sensor can also measure air quality. And it was a thing where they were measuring the air quality inside an office building, and they would sound alarms when the air quality would go down. It's like having the really cool smoke alarm we had earlier, but one that's connected to the internet. So way cooler, right? Okay, so let's write some JavaScript. Now, this is how you deploy a cloud function. This is the command you run to deploy a cloud function. I'm not going to deploy the cloud function in the demo because then we're going to sit twiddling our thumbs for approximately 2 to 5 minutes. So you just need to trust me that the code we write here is the code I have on Google Cloud. Okay. Cool. All right, let's write some functions. So firstly, we're importing the Google APIs, and we're using this config file. The config file has similar stuff to our other config file. It has the name of my project. As you can see, I have very creative names. The cloud region we're in, the registry, and the name of the names of our 2 receiver devices. Relay Cloud IoT is the name of our function. And inside here, we can start reading the data we're getting. So logging the data, again, debugging purposes, didn't take it out just in case something breaks. And then we pass it to JSON, pass the data to JSON. One of the cool things about this is because this function is running in the same project that the IoT devices are running in, it's really easy to authenticate. So you just call google.auth.getClient, and that's it. You're authenticated. So you can get the information. Once you're authenticated, you can set up your registry name. The registry name is quite a long thing. So the project ID, then the location, and then the registry ID. Okay. Now we can interpret the data we're getting from the pub subtopic. So, if we get light data, set our device to the light device and get the light reading. If we get temperature data, set our device to the fan device and get our temperature reading. And lastly, we can send this on to Google Cloud. 6. We do that by creating a request with the name of our device. Version to update is 0 because this is still the first version of our devices and we count from 0. And then the data. And then the important part here is this modify cloud to device config. So remember, we were updating the config bit on our devices and sending that request. All right. So if everything is still working, and press escape here. Allow that so I can show you what's actually happening. So this is my little sender device. Here it is. I'm going to plug it into this power bank. And it's going to take a few seconds to start up. You can see it's trying to connect to the Wi-Fi. It's connected to the Wi-Fi, now says that MQTT started. Now it's going to start sending messages. It says messages sent, the fan has turned on. If we cover up our light sensor over here, when it sends the next message, next message. Come on. Light turned on. Ooh. So all of this stuff is really cool and fun to play with. And you can use it to automate a whole bunch of stuff inside your house. And one of the things we're going to be using it for is building a fridge that lets you know when it's been off for too long because you've had load shedding, so your food might have gone off, you know, stuff like that. Or that your beer is cold enough, you know. Either way, important stuff, the important stuff. But what about some real world stuff? Well, I looked into a few real world IoT projects. One of the ones I found is something called Amazon Dash Button. It's really cool. So this one is an example of washing powder, but you have to have an Amazon Prime account. So the Amazon Prime account lets you have your credit card details and stuff stored in there. You get a whole bunch of these buttons for different products. And when you push the button, it goes and orders that product from Amazon, puts it into your cart, and pays for it, and ships it to you straight away. Like, it's pretty cool, but it only works in America. So something closer to home. Maybe, it's possible. Not one programmed with JavaScript, though. Yeah? Oh. Makes sense, makes sense. And another example a little bit closer to home. So a lot of shops in South Africa have this problem with their trolleys being stolen. And apparently they lose millions of rands every year because their trolleys get stolen. So this company, South African company, came up with these little beacons that they can attach to their trolleys. So they have antennas around the shop. And when a trolley goes out of bounds of a certain area, it can sound an alarm or something in the shop to say, okay, this is where your trolley is, go and retrieve it. which is pretty cool. And the last one, and probably my favorite one, is a beer keg tracking system. So this is really cool because companies that produce beer and sell beer kegs to restaurants and things can track where the kegs are, how empty or full they are, so they know when to replace them. But what's really cool about it is that they also have a consumer app for it. And the consumer app can tell all of us where our favorite beer is, how cold it is, how fresh it is, and we can go and find it. Now, I know you're all feeling a little bit like this right now, but I do have one more thing to show you. My big red button. I promise this is not why we got kicked out of the building earlier. It's not that dangerous, although it could be. Now, I like beer. Beer's okay. But I really like wine. So this button lives underneath my wine rack at home. And every time I run out of wine, I push my button. And it goes to my favorite wine farm's website and orders me a bottle of my favorite red wine. And if I push the button again, it orders me another bottle. Thank you very much. Are there any questions? Yep.
How much longer until I can program in JavaScript on the actual device?
So there's a thing called JerryScript. I really wanted to use it, but I didn't have enough time. But yeah, so it's a C library that has been compiled in such a way that you can write JavaScript and run that on the device. Yeah, it seems pretty cool. Maybe next year. Yeah.
You can load the Esprit framework on all Arduino and ESP devices, so it's native JavaScript.
Is there enough space for node modules?
No. And there is also JohnnyFive. You've used JohnnyFive before. But JohnnyFive only works on Arduinos. So the ESP devices don't work so well with JohnnyFive. But there is a very small Arduino. Might be close enough to an ESP32. Anyone else? No. Yeah?
Can your husband have his fan back?
Yes, he can now. He may need to solder it back together because I'm not soldering it. Anyone else? Yeah? So they range. So we got a whole kit. I think our kit, which has a lot of different sensors in it, was about 1.5, 2,000 rand. And it has a lot of sensors in it, but you can also buy them individually, so like specific ones. One of the ones I really want to buy and put in the bar in our office is a breathalyzer. So you're not allowed to drive your car if you can't pass the breathalyzer test. Thank you.